Hello and welcome friend. In this video we discuss about the derivative of the inverse hyperbolic functions. Here let us see the derivative if y equal to tan in suppose first we consider the sine function sine h inverse of x, then we can write it as x equal to sine h y. Now differentiate this with respect to y, then we get here dx divided by dy equal to cos hy, since derivative of sine is a cos hy hyperbolic. Okay, so let us take the reciprocal of this, therefore we get dy by dx equal to 1 divided by cos hy equal to, here we know the identity cos h square x minus sin h square x equal to 1, right, and therefore cos h square x equal to 1 plus sin h square x. Therefore here we replace here the term 1 divided by under root of 1 plus sin h square y, sin h square y, and this is equal to, here you can see that y is equal to sin h inverse x. So sin h inverse of y is equal to 1 divided by under root of 1 plus x square, and hence d by dx of derivative of sin h inverse of x equal to 1 divided by under root of 1 plus x square. Now let us see the derivative of cos. If my function is y equal to cos h inverse of x, then we have x equal to cos h y. Let us differentiate this dx divided by dy. Derivative of cos is nothing but sin hy. Then dy by dx equal to 1 divided by sin hy. 1 divided by sin hy. So here sin hy is nothing but 1 divided by under root of cos h square y minus 1, and cos h square y is what? Cos h square y. Here cos h square y is a x. So this is equal to 1 divided by under root of x square minus 1, and therefore d by dx of cos h inverse of x equal to 1 divided by under root of x square minus y. You can see that here sin hy equal to x and here cos hy equal to x here. Therefore derivative of sin h inverse of x equal to 1 plus under root of 1 divided by under root of 1 plus x square, whereas the derivative with respect to derivative of cos inverse of x equal to 1 divided by under root of x square minus 1. Now let us find the derivative of tan inverse function. Derivative of tan inverse d by dx of so tan inverse of x, we are y equal to tan inverse of x. This implies x equal to tan of y. Hence dx divided by dy, this is nothing but sec here, sorry, this is we are discussing about the function, hyperbolic functions. So let us take the derivative of y equal to tan h inverse of x, tan h inverse of x, therefore x equal to tan h of y. Then dx divided by dy equal to sec h square of y. Okay, again cos h square of x minus sin h square of x equal to 1. If we divide it by cos h square, so we get here 1 minus tan h square of x equal to sec h square of x. So we have here this is equal to 1 minus tan h square of y. Hence dy by dx equal to 1 divided by 1 minus tan h square of y equal to 1 divided by 1 minus x square, and hence therefore derivative d by dx of tan inverse of x or tan h inverse of x equal to 1 divided by 1 minus x square. Now let us find the derivative of sec. y equal to sec h inverse of x. This gives x equal to sec h y. Then dx divided by dy equal to minus sec h y into tan h y. Okay, so again use the identity cos h square x minus sin h square x equal to 1. Now dividing by cos, we have 1 minus tan h square x equal to sec h square x. This gives us 1 minus sec h square x equal to tan h square x. Right, we are transferring these two, interchanging these two terms. So here we replace this value minus sec hy into 1 minus sec h square of y. Therefore dy by dx equal to minus 1 divided by sec hy into 1 minus sec h square y. Okay, here we have tan hy, so therefore we have here under root term, under root of 1 minus sec h square y. This is equal to minus 1 divided by sec hy. What is sec hy? X into under root of 1 minus x square. So dy by dx equal to minus 1 divided by x into under root of 1 minus x square. Similarly, we can find the derivative d by dx of cot h inverse of x equal to minus 1 divided by x square minus 1, and d by dx of cosec h inverse of x equal to minus 1 divided by x into under root of x square plus 1. So this is about the derivatives of the inverse hyperbolic functions. Thank you.